for the next problem, let's start by graphing the line 6x minus 4y is less than or equal to 10. So again, what we can do is put this in slope-intercept form by first subtracting the 6x from both sides. That would give us a negative 4y is less than or equal to negative 6x, and that's a positive 10, so plus 10. Then the last step would be dividing both sides by a negative 4. Be careful though, dividing both sides by a negative will flip the direction the inequality is pointing. So this will become y is now greater than or equal to. Now we need to reduce the negative 6 over negative 4, which will turn into a positive 3/2 x. Now, for the last part, we have a positive 10 divided by a negative 4, which will give us negative 5/2. Negative 5/2. So to graph this first one, again, we'll do a mock-up. Notice it will be a solid line because of the equal to. We will start at the negative 5/2. That's the y-intercept, which is about negative 2.5. And then we'll use our slope, which is rise over run, which is 3 over 2, which means we'll go up 3 and over 2. So up 3, 1, 2, 3. We'll put us partway in between 0 and 1 going up. And over 2 puts us over at 2. So, and now we can draw our line, which will again be a solid line. And let's do that same line over here so that we don't forget on our final graph, which again is right between 2 and 3 on the negative side. And then we're going to go up 3, 1, 2, 3, and over 2. And draw our solid line. We'll save the shading on our final graph for at the end. So how do we shade this graph? Well, we need to, again, test a point. Let's test 0, 0. So plug in 0 for x and 0 for y. Again, we're testing 0, 0 to see if it works, to figure out which side to shade. Notice that this will give us that 0 is greater than or equal to negative 5/2. And that is a true statement. 0 is always bigger than a negative number. So that means we will shade the side that 0, 0 is on, which means we'll shade above the line. The second part to this graph is looking at the line y is less than 2. For that line, we have a horizontal line at y equals 2. And notice, because it's less than, not less than or equal to, it will be a dotted line. So I can go ahead and draw that in on both of my graphs. And notice, again, I'm going to test the same point, 0, 0. So we'll plug in 0 for x and y. There's no x to plug in, so just y. And we do get that 0 is less than 2, which is a true statement. So 0, 0 does again work. It does work. So we'll shade the side of the horizontal line that contains 0, 0, which means we'll shade the side that's below that line where 0, 0 is. So in our final answer, we only want to include the overlapping portion of these two graphs, which is this little triangular piece. So we have both graphs, both lines already on our final graph. We just need to do our final shading, which should only be that overlapping triangle in the lower left-hand side here. And that's our final answer. Now for another problem. Let's start with our first graph. X minus y is less than 1. Again, let's put this in slope-intercept form. So we will subtract the x from both sides first, which will give us negative y is less than negative x plus 1. Now we need to get rid of that negative or negative 1 out in front of the y, so we'll divide both sides by a negative 1. Again, remember that this will switch the direction of the inequality, giving us a greater than now. But dividing the right-hand side also by a negative 1 will turn our negative x into a positive x and our positive 1 into a negative 1. So let's do our little mock-up over here. Well, that means drawing our first graph here, we're going to start at the y-intercept at negative 1. And our slope, which is kind of hidden out in front of the x, is 1. So that means we'll go up 1 and over 1. And notice we do have a greater than, not a greater than or equal to, so this means we will have a dotted or dashed line. And again, notice I'm putting it on both graphs so I don't have to remember how I drew it. And now we'll only do the shading on the final graph by testing a point. We'll test 0, 0 because again it is not on the line. So let's plug in 0 for x and 0 for y. Notice what that gives us is that 0 is greater than negative 1. Is 0 greater than 1? Is 0 greater than negative 1? Absolutely. So that point does work. So we will shade the portion of the graph where 0, 0 is on, which means we'll shade the portion of the graph that's to the right or above the line. Now let's look at the second graph. The second graph is a little bit unusual. Notice the second graph is y needs to be between negative 1 and 1. So what that is actually two horizontal lines, one at negative 1 and one at 1. Notice there's no equal to's, so what that means is that they're both dotted or dashed at positive 1, and then there's one at negative 1. Again, I'll do this on my final graph too, at positive 1 and at negative 1. Now notice it says that they should be between negative 1 and 1. It says it should be less than 1 and greater than negative 1, which means that should be this little interior piece. If you weren't sure though, you could test the value 0, 0. And notice you would get that 0 is less than 1 and 0 is greater than negative 1, so it would work. That's why you're shading in between those two graphs. The question is, what are we going to shade in for our final answer? Well, our final answer is, again, only the overlapping section, which is this oddly shaped quadrilateral over here. So only that little shaded piece in the middle, that little quadrilateral, is what's going to get shaded in our final answer. And there we are. We're all done.